Welcome to WEFTEC Now. I'm Travis Loop with the Water Environment Federation. Very excited to be here with some folks from AdEdge. I have Chris Savino. He is Regional Sales Manager. I have Tyler Butel. He is a Technical Sales Engineer. How are you both doing?
Doing great.
Excellent.
For the conference.
Yeah.
Yeah, glad to be here.
We have a really hot topic to talk about here, and that's PFAS. This has been in the news a ton for a while. It's one of the biggest issues in the water sector right now, without a doubt. So I'm excited to have this conversation. Tell me, just to start, what is PFAS?
Well, yeah, PFAS itself is a whole family of compounds. It's not just an individual compound that's in the groundwater. It's a long-chain fluoropolymer, combination of fluorine and carbon. Very, very strong bonds, but it's a man-made compound, really originated back in the 1940s, almost as a missed science experiment where they're trying to make an alternate refrigerant, and next thing you know, they made this product, was just the PFAS compounds, which is also a precursor to Teflon, and a lot of the products you're going to see in the marketplace, and it's in a lot of other things besides Teflon.
Well, could you give some examples?
It's in textiles, it's in waterproof clothing. If you have Scotch Guard in your car, you have PFAS in your car. If you have, the pizza boxes, hamburger wrappers, just a whole slew of things that is actually where PFAS is actually in contact with those materials.
Wow. And so what's the concern about PFAS?
It's really a combination of the compounds themselves. Once they're manufactured and once they're in the environment, there's nothing that degrades them. So it also now gets into the food chain, and now you have greater exposure to individuals, and anybody else that's getting exposed to it gets into their system.
Yeah, there's a movie coming out actually, Travis. It's called Dark Waters. I'm sure you've heard of it.
Yes.
with Mark Ruffalo. So it's serious enough that they brought in the Hulk, right? And all jokes aside, we know that from studies. So PFOA and PFAS are the two most well-known PFAS compounds, and they've been studied, and there are very real health risks, and there are links to, and I don't want to get this wrong, so I'm just, if you'll allow me, just to read the list of the health risks that are there. So higher than normal incidence of cancer, liver enlargement, hormonal changes, thyroid function, elevated cholesterol, reduced birth weight, structural defects, increased neonatal deformities. So obviously things that we should be concerned about. So the problem with the PFAS compounds is they don't degrade quickly, especially PFOA and PFAS. They're long chain, and they bioaccumulate. So they're essentially increasing in concentration in your body. The good thing is that these compounds, the longer ones, their use has been curtailed, and now we have new PFAS compounds. They're actually shorter chain, but we don't know a lot about their health risks yet because we haven't studied them. I think as a general statement, the further a compound is away from what nature would make, the more likely we should be concerned about the impacts it has to humans. And so I think it's smart to err on the side of caution that any exposure to PFAS is bad exposure.
And I know there's a lot of new science underway to try to learn about these health effects.
Lots.
Everything that's been happening in the news the past few years has sparked a lot of that research, and so
Exactly.
we're all kind of waiting to see
Yeah.
what this science tells us about the health effects.
Right.
And some of the exposure levels have just kept getting lower and lower and lower. If you look at the individual states, they've been dropping it further and further. It's combinations, also detection limits. Look at science 20, 30 years ago, the best they could probably get to was a couple of parts per billion or less. And now you're down to parts per trillion levels. Kind of keep that in mind, parts per trillion. And it's something hard for most people to imagine of how low of a concentration that really is.
And that's with science, it's allowed us to do these detections of much lower levels. But then it's also getting to these low levels where you're like, is that a risk for human health or not? It's a kind of new frontier we're in with a lot of these emerging contaminants, right?
Correct.
How does PFAS and the family of chemicals, compounds, get into water?
Well, because it is what I'll call almost a non-destructible compound, it can get into water. It can get into the if it goes into your wastewater, if it's in the water and it goes into the wastewater plant, it's now being discharged as part of the wastewater. So now it's going downstream to the next treatment plant. Could be a drinking water plant, wherever else is going to be used. The sludges from those wastewater plants could be going to a landfill, and it's going to leach out of that. So now all of a sudden you have the PFAS compounds coming out of that, the solids, leaching into the groundwater. And there's also, there's also direct entry into the groundwater. You may have a chemical spill. There have been instances in New Jersey where a particular plant was using a PFAS type compounds and are just slowly dripping into the groundwater until one of the drinking water plants several miles downstream found it. And they had to keep going back upstream to find out where this was.
So industrial
Yes.
sites and discharges is one of the sources where it gets into waterways or groundwater.
Yeah.
And one of actually the biggest things when people started finding initially, and you hear all the stories out there around I'll call it the Air Force bases or military bases, is because they're using the firefighting foam. They're called the advanced firefighting foams. And these are just chock full of PFAS compounds. So when the crews go out there and practice, they spray the foam across the runways, they rinse it off, and it goes right into the aquifer.
Yeah, I know a lot of the communities around military bases and so forth around the country is where there's a lot of concerns and heightened levels of
Exactly.
PFAS. Yeah. You mentioned parts per billion, parts per trillion. What are some of the different levels that are being found out there? in
Yeah,
water?
so near those direct sources like firefighting foams around the Air Force bases, you're seeing a lot higher levels. And then in, say, drinking water wells from municipalities or private water utilities, you might see some in the 100 part per trillion range, but most of it is going to be under the 70 part per trillion range, and then all the way down to single-digit parts per trillion. So, like Chris said, parts per trillion is the common analogy is 1 grain of sand in an Olympic-sized swimming pool. That's what we're talking about.
Think about that.
So the levels are pretty small. And what we see is, of course, we have the EPA's health advisory limit at 70 parts per trillion. It's just the health advisory limit. It's not a maximum contaminant level. And so states, the response from the states has been, in some cases, for them to set their own contaminant level and have it actually be a regulatory level. Other states are following suit with lower health advisory levels, and every state has a different number, and so you need a table with lots of columns and lots of states to know all the exact numbers. But what we see is that they're really taking it into their own hands to protect their customers. And I think just to give you an idea of, like, let's say the state of Michigan, what are they actually looking at? And so I'm gonna break out my notes here again, because there was a study done, and they looked at 1,741 water systems. Now this could be community water systems, schools, daycares, tribal entities that made up that 1741. The amount of systems that had over 70 parts per trillion, which is the health advisory by the EPA, was 2. Two.
And these are drinking water systems.
Drinking
we're
water
talking
systems.
about.
The amount that had it between 10 parts per trillion and 70 parts per trillion was 62. And what that means is that represents a population of 490,000 people drinking that water. Below 10 parts per trillion is 1.4 million people, and then non-detect is the majority. The rest of the people have non-detect. So we're really looking at a lot of people between non-detect and 10 parts per trillion. And now we have to figure out, what does that actually mean from a risk-based standpoint to health?
Yeah. I want to reiterate the point that you all made, that the real exposure to people, to Americans of PFAS is through all these other places, right?
It's
Through
ingestion, through drinking water, it's bioaccumulating in the food chain. So there's fish that'll accumulate, not necessarily in the muscle tissue of the fish. So you think, okay, you take away the fatty tissue, you just want to eat the meat of the fish. Well, that's actually where it's going to accumulate, where the blood flows are greater into the meaty parts of the fish. So that's partly can get into the food chain that way. So you do have to be careful there as well.
Well, let's pivot to solutions, because I know that you all and AdEdge are really focused on this, on the solutions side of things. How can you treat for PFAS? How can you remove it from water? What are the best ways to do that?
I mean, right now, there's a lot of technologies that are out there, kind of chasing how you treat for it. The primary, I guess call it the two primary treatment methods are either granular activated carbon or ion exchange resins. It's basically an anion type resin that's used as a once-through type process. Each have their own advantages. I mean, the GAC systems are slightly less expensive in terms of the media, but you need a much bigger system, much higher contact time. In order of magnitude of anywhere from 5 to 10 times more contact time with carbon as opposed to the contact time with the resin. So on an ion exchange resin-based system, it's going to be a smaller footprint, but you have a higher cost for the media that's going to be used for that smaller footprint.
Am I correct that though, even with the carbon, then you have to do something with some waste at some point?
Yes.
Yeah.
Once again, each of these are the medias that are going to be a spent media, so at the end, the only solution that's currently out there for that spent media, because you don't want to take it and just put it back into a landfill, because then they're just never getting out of the cycle. You actually have to take the spent media, send it to an incineration, and the guidelines currently are sending it to an incinerator that's upwards of 1100 degrees C before it's actually destroying those compounds.
Mm-hmm. So these two types of treatment, how prevalent are they at water utilities, and are you seeing more water utilities start to put these in place to head off concerns or deal with contamination?
That's like a great question. It's actually, I always try to tell people there's kind of a sprint right now between regulations, and some of the regulations that Tyler just gave you, we talked about the different regulations in the states. Some of these are fresh off the printing presses. Literally, I mean, regulations in some of the Northeast states were just issued this spring. So all of a sudden now, these towns have to come into compliance. They're trying to figure out do I need an emergency system? Do I need a long-term solution? But every one of them is concerned about putting in a long-term solution for those facilities.
And it's not cheap technology to implement necessarily. It's a significant investment to put this in
Correct.
place. Yeah.
It
And
is.
there are regulations, but they're not really receiving funding to deal with that. They've got to figure out how to fund and install this type of technology.
And generally, it's going to go through their rate base, the rate payers, you and I, who are using our tap water in our homes every day. We're the ones who are going to have to pay for it. That's where it's going to come from.
Yeah, very interesting. I want to talk about maybe some specific projects you all have. I think you have some work going on in New Jersey.
We do, yeah. In Bergen County, up in northern New Jersey, we have a project at a city called Ramsey. And this is just a great project in terms of the engineers in the city. They did a fantastic job responding to a really tough situation. In fact, it's not only PFAS. They have arsenic treatment at 6 individual well sites across the city. These well sites are in residential neighborhoods, so they can't really go any bigger. And one of them is actually in the middle of a highway interchange loop. So they have to coordinate with DOT. And so they have arsenic treatment already there, and pH adjustment and all these other treatment processes. And they found out that the media that they were using for arsenic treatment was going to run out. It's not going to be manufactured anymore. And by June 2020, this is in 2018 of October, by June 2020, they're not going to have any arsenic media available to them. So they found us, the arsenic treatment experts, and we started working on a project with them and helping them figure out what to do. Well, they started testing the water quality again at all these wells, as you should when you're looking at putting in a new design. And what they find?
PFAS.
They found PFAS at 2 of the 6 wells. Now, New Jersey, their limit for PFOA is 14 parts per trillion, and the 2 wells were right at 14 parts per trillion. So Ramsey had to decide what to do. Do we put in treatment now? Or do we take the risk? And we commend them, of course, because they went ahead and added PFAS treatment along with the arsenic treatment. So 2 of these sites, they're completely containerized systems. We call them our water pods. So they're built in 53-foot long shipping containers that are completely redone, have beautiful interiors, and all the system is inside that container. It has ion exchange treatment for PFAS and then arsenic treatment as well. And so this is going to be our first install for PFAS treatment, and one of the first fully permitted. Right now, it's temporarily permitted. That's how it works in New Jersey, and it's going to be one of the first permanently permitted PFAS treatment systems in New Jersey. So we're very excited about that, and that's going to be coming spring next year, summer next year, as we install and manufacture all these systems.
I imagine towns across the country will be looking at examples like that and seeing how a town steps up and deals with the situation and
Yeah,
puts that in
they're
place.
they're contacting their engineers saying, I have this in the water. And so engineers are having to evaluate a lot of different alternatives, and I think that's where AdEdge comes in. That's what we're really good at, is working with all the engineers and helping them figure out what our options are. Because we're a custom treatment system manufacturer, so hey, we can put the solution together that you need for that specific site in the middle of a highway interchange loop, or in the middle of a neighborhood, or wherever it might be.
Yeah.
You look at that, but also even like some of the larger systems, the one up in New York State, they put a groundwater treatment system in. The whole plant had to be several $1 million to treat for common iron manganese problems. They go to start up the plant, PFAS.
Yeah.
Wow.
5,000 gallon per minute plant can't be run because of PFAS in the groundwater. I mean, it's just
The challenges are incredible.
and this is in a known area that has contamination. I mean, up there in the Hudson Valley. So every customer and anybody who's looking at a new design for a plant today, first question they have to have is, do I have PFAS in the water? One of the customers we were with last week, not that she was hoping to have PFAS, but if she had PFAS in her well water, she got higher on the priority list to get her plant approved. So rather than just treating for iron manganese, I mean, she would have had a higher probability of getting her plant approved right away, just because if she had PFAS in the water. And the states are taking a really hard look at this, and some states actually, they're going ahead and actually putting plants in ahead of getting into regulatory approval. They're just going ahead and helping out the towns.
Sure. Last question. What does it feel like to be working for a company, and yourselves professionally on just such a cutting edge issue that's got so much attention, that's so important for public health? What's that feel like to be part
So
of?
AdEdge started with arsenic treatment. So it's very similar to those early days with arsenic. And so I'm very proud to work for a company that's solving a very serious issue for a lot of people all over the country, and it's going to continue to be the conversation. And so we are proud to bring those solutions to people.
Sure.
And there's a passion for clean water. This is what we always think about a project by project basis, but there's a passion for clean water. So last week, sitting there having my breakfast and looking at my iPad, what do I see? The movie trailer for Dark Waters, and all of a sudden, like, it goes off like a bell in my head of like, oh, I got to start sharing this with everybody in the company because it's so important.
Right.
It's such it's a scary story, but it's a great story at the same time because it really exposed what's out there.
Yeah. Well, Chris and Tyler, thank you both very much for the information. Very informative on an incredibly important topic. Thank you all for watching. For more interviews, please check out weftec.org/now.